Hello friend, today we'll discuss about 01 knapsack using branch and bound. So already we can know the 01 knapsack concept that is already solved by dynamic programming. So 01 and fractional knapsack already solved by greedy method. So 01 knapsack means here no fraction will be checked, fraction part will be taken in knapsack or bag. So here we can consider total profit or weight of a particular object. So for solving it by state space tree, we can solve by branch and bound. So 01 steps are mainly we can solve by branch and bound approach, but branch and bound only solve the minimization problem, but it is a maximization problem. Already we can solve by maximization problem because whether which one the profit of any object, which one profit is maximum, so we can get into snap or bag. Then we can fill the bag accordingly. So here we can take an example, that is here some four object is there, and each object have different profit and different weight will be taken, and one snap will be taken or bag, that is 15 m is equal to 15, means maximum capacity is 15 kg you can say, or gram we can, or anything we can say. So we can say as kg, so 15 kg bag is there, so we can put at it cannot be greater than 15, the capacity is not greater than 15, so as like as you can fill the bag. So here we can follow the in branch and from branch and bound we can follow the LCBB method, that is least cost branch and bound method. So here we can take each node as a cost belonging, which minimum cost is there, we can take this type of node, or uh, we can expand this type of node only. So here we can know the solution can be solved by two calculation method will be there, that is one is taken as a subset of any object you can take as a subset, or you can solution will be as like as in this form 1010, that is 1 is include for including and 0 is not including in the snap or bag. So here we also can take the for getting or solving the state space tree, we can take the upper bound. For upper bound you can take the one formula, that is sum of n is equal to I is equal to 1, and that is pi xi. Pi means the profit and xi means the object, so or c is equal to also, but in cost we can take as a fraction, and all to this part for upper bound or either cost. Here for both we can check that is not less than or equal to m, means maximum capacity of the knapsack is not less than, it always less than and equal to the snap or bag, not greater than or equal to the snapsack or bag. So we can fill the bag. So here we can take as a maximization problem. So here for solving the problem we can or get the solution, we can take as a upper bound and also with the cost as a negative sign. So you can calculate always in negative sign, but the it not taken as in solution, it only solve the problem for solving the problem and get the result. So the total time will be here the 3, so here J2 does not require 1 hour. So here we can generate the state space tree. So here we can take in the first node, that is 1, and for we can also be maintain the parameter, that is upper parameter, and here initially we can take the upper parameter as an infinity, and for by calculating part we can as first calculate u, then c also for generating the first node upper bound and cost of the first node. So here we can calculate the upper bound as we can take the 1 2 and 3, that is profit, object 1 object 2 and object 3 profit, that is 10 10 and 12, that is 32, and we can avoid the object for because here the profit is 18, but it can cross the snap weight or maximum capacity. If you add 4 6 and 2, that is 12. If you can add the also object 4, its weight is 9, so it can cross the maximum capacity of snap, that is 15. So for getting the object 4 as in node 1, so we can calculate as so we can calculate object 4 as we can divide the object 4 profit by weight, object 4 weight, so we can get it is as 2, and the difference between the object total capacity of snap, that is 15, and the total weight of the object 1 and object 2 and object 3 is 12. So we can subtract the to them, so we can get 3. So the total capacity is now 3 into 9 by 18 means 2, so 3 into 2 means 6. So the now the cost is now 10 plus 10 plus 12 plus 6, so now we can cost the 38. And you also consider that it's not, you cannot here we can see in formula that you cannot take any fractional part, so you can be calculated as minus 32, and is minus sign will be taken for getting the solution, but it is not in solution part, it can only the solve the problem. So we can take as a minimum. So from infinity the minus 32 is minimum, so we can take the minus 32. So as like as the all path will be taken and all part will be calculating as like as upper parameter. So when minus 32 from minus 32 is less is coming, so we can cross the minus 32 and get the minus 38. So as like as the process will become, so at last we can get the parameter, that is or path, that is 1 to 2 2 to 4 4 to 7 and 7 to 8. So last in 8 part we can say or 8 node, this can be only expendable, but others all are cross sign, means you already know the cross sign means killed node, that is already killed, only 8 is remaining, that is not killed, means it can be expendable. So here we can generate and all part will be covered. So from here we can generate the path, that is 8 7 4 2 1. So from 1 to 2, that is it can be generated, so it can be taken or it can be included. So there will be 1, and here also be it can be included, that is also 1 plus, so 1 plus 1, and here 4 to 7 is also included, but is its also value is 0, and here also be included, that is value is 1. So we can take 1 1 0 1. So as like this you can show the snapshot 01 snapshot problem, because we already know that two calculation method is there, so we can take this type of calculation method, because here we can 01 snapshot always calculate by 1 or 0. So 1 is for include and 0 is for not include. So at the last part we can get the result. So from we can include the path, that is first is include, second is include, and third is include. So here we can see there have three, we can take three part, that is include 1 2 and 3, and the calculation is 1101, that already I will say. the profit of for the object is 10 plus 10 plus 0 plus 18. So from this path we can get the profit, that is 38, and the weight of the capacity is same as the capacity of the bag. So it can also be again 2 plus 4 plus 0 plus 9 is equal to 15. So we can get 2 plus 4 plus for object 3 is 0. So 2 4 plus 0 plus 9 is equal to 15. So total capacity also be filled, and the result will become 10 plus 10 plus uh, so 10 plus 10 plus 0 plus 18, so is as 38. So you can get the profit as 38. So as the 0 1 snap snack using branch and bound will be solved. Thank you everyone.